We talked about having a population with n subjects in it. So this is our population. And taking a random sample of that population to get some smaller sample with lowercase n subjects in it. And it's this process right here that I'm drawing with the arrow that we're going to be talking about in this video. Because what we always try to do is randomly select people from the population for our sample. So we're hoping that this is random selection. If this is perfectly random selection, then we're hoping that we eliminate bias from the sample. And the goal is to get a perfectly representative sample. Because if the sample does perfectly represent the population, then when we calculate information about the samples, when we look at the characteristics of the sample, or the sample statistics like the sample proportion p hat, or the sample mean x bar, then we can use that information to make inferences about what we're really interested in, which are population parameters like the proportion p or the mean mu. If the sample is perfectly representative, then basically we can just take our results for the sample statistics and scale those up to the population because we know the sample does a perfect job representing all of the people in the population. So an easy example of that could be, let's say I have a fruit salad. I have a bowl of fruit salad like this, and the bowl holds 20 cups of fruit salad. If the fruit salad is perfectly mixed, then every little 1 cup section should have the exact same ratio of pineapple to strawberries to grapes to apple slices, whatever, in that cup. If I take another cup as a sample and take that out, it's going to have the exact same ratio of fruit as the other cup. And all 20 cups in here, if I take them out, they're going to have the exact same ratios of fruit because the fruit salad is perfectly mixed. So if I were to take one of these cups out and it's a representative sample, let's say I take the 1 cup out and I find that there are 2 strawberries in the 1 cup. So I would say there's 2 strawberries in 1 cup of fruit salad. And if I know that the fruit salad is perfectly mixed together and every cup is identical, then I could say that there are 20 cups total in the fruit salad. So how many strawberries are in the full fruit salad? Well, really what I just have here is 2 over 1 equals x over 20, or I could write that as 2 is equal to x over 20. I could multiply both sides by 20 to get 40 is equal to x. So I would know that there are 40 strawberries in the fruit salad. But that's only the case if this 1 cup that I took was a perfectly representative sample because the fruit salad was perfectly mixed. But if more of the strawberries are in the bottom of the bowl down here, and I take a 1 cup sample from the top, I may not get a representative number of strawberries. So that's the reason that we're looking for a perfectly representative sample. We want to just be able to take what we know about the small sample and scale it up to the population or make inferences about the population. And this is a really simple example, but a lot of the times the reason that we don't have a representative sample is because of what's called bias. And really, there are 3 main kinds of bias that we want to talk about. There is response bias, there is what's called undercoverage, and there is non-response bias. Response bias basically means there's something wrong with the way that we collected the data. For example, we could have broken tools or tools that are not calculated correctly. For example, if we're collecting data about temperature, but our thermometer is broken, we're going to have measurement bias. There's something wrong with the tool that we're using. So the responses that we're getting from our subjects are going to be biased. This could also be something like an embarrassing question or a question that people don't want to answer. For example, if I ask the question on a survey, have you ever stolen something? People might be incentivized to lie because they're embarrassed about giving a truthful response. Or if you have something like biased wording in a question that makes people want to answer a certain way because you have a judgment already in the question. Like, have you ever rudely interrupted someone when they were talking? Somebody might see that and think, well, I don't want to be rude, and so they don't answer truthfully. Even if they have interrupted somebody, they say that they haven't because they don't want to be rude. So you have this biased wording that creates a judgment that incentivizes them not to respond truthfully. So all of these things are really about the instruments that we're using to measure, whether it's a survey or whether it's some kind of tool like a thermometer or a ruler or something. There's something about the data collection tools that we're using that's going to cause us to get some kind of biased response. We lump all those together in what's called response bias. Undercoverage is when we leave out a large group of people. So, for example, if I run a daycare center and I want to learn about the income of the parents of the children who I take care of, I could maybe ask those parents as they show up to pick up their children how much money they make on an annual basis. Well, if I only ask the first 5 people who come to pick up their kids, maybe the people who get off work the earliest make the least amount of money because they work the least. Or maybe they make the most amount of money because they're in a financial situation now where they don't have to work as much. I'm leaving out the whole group of people that come later to pick up their kids. So I'm really getting a biased look at the annual income of my parents. So basically what we're doing here is we're leaving out a group of people, but my daycare example might be called selection bias. Another example of undercoverage would be voluntary response sampling. So voluntary response sampling, which is when I only get responses from people who choose to respond to my study. Well, if I'm only getting people who voluntarily choose to take my survey or respond to my study in some way, they might be responding for a reason. Maybe they have more time on their hands. Maybe they're more enthusiastic or passionate about whatever it is that I'm trying to survey. Maybe they have access to resources that allow them to take my survey, whatever it is. But basically, I'm leaving out the entire group of people who, for whatever reason, choose not to respond to the survey. So I'm introducing bias there if I'm just going off of voluntary response sampling. And then you have convenience sampling, where I'm just sampling people based on whatever is convenient for me. So maybe I want to ask people about their eating habits. Well, if I just go stand outside a healthy grocery store and ask everyone who walks out the door about their eating habits, because that happens to be convenient for me as the researcher, I might get a totally different picture of the results compared to if I go stand outside a fast food restaurant, because that's more convenient for me. I'm potentially really skewing my results either way. So these are all slightly different examples of undercoverage. I'm just leaving out a group in one way or another. And then the last one is non-response bias, which is similar to undercoverage, but basically it's just that there are a lot of people who didn't respond to my survey. We specifically call this out when we have something where maybe we do a poll and 98% of the people that we asked don't respond to our poll. Our biggest problem there by far is non-response. It may be true that there are other kinds of bias in our data. So for the 2% that did respond, maybe there was some kind of biased wording issue we have to be aware of. But a little issue in our 2% pales in comparison to the fact that we didn't get 98% of people to respond to our survey or our poll. Our biggest issue by far is non-response. So if that's the case, we want to specifically call out non-response bias to indicate that that may be an issue that's skewing our results. Now, regardless of the kind of bias that we have, we always want to be able to think about the direction of the bias, what's called the direction of the bias. And basically, we're just paying attention to the direction in which our results might be skewed. So going back to our grocery store example where we stood outside the grocery store asking people about their healthy eating habits, maybe we are trying to get an idea of how many servings of fruit per day the average American consumes. But we just went and stood outside the healthy grocery store and asked the people who walk out how many servings of fruit they consume on average per day. What we would want to say is that because we used convenience sampling and we stood outside the healthy grocery store, we would expect that the participants in our survey eat more fruit on a daily basis than the average American because we're standing outside a healthy grocery store. So what we would want to say is that we might be overestimating the number of servings of fruit per day that the average American eats because of the way that we sampled. Maybe in another instance, we are underestimating, for example, here with our biased wording when we asked people if they had ever rudely interrupted someone or if they had ever stolen something. We might say that the number of people who answered yes to either of those questions is actually still an underestimation of the true proportion of people who have done that, because people will be inclined to answer no when truthfully they should have answered yes. So that might be an underestimate versus the grocery store example might be an overestimate. We always want to be aware of the direction of our bias. So given that there are so many ways to introduce bias, what do we do to try to avoid this kind of bias and get a good, unbiased representative sample? Well, one way is to use a random number generator on a computer. Just give everyone a number, so assign every subject in our population or everybody that we can ask a random number, and then use a number generator to pick out random numbers, and then the numbers that it spits out are the ones that we include in our sample. Doing something like that is what's called a simple random sample, which we often abbreviate as an SRS, a simple random sample. While that would be completely random selection, what we're talking about over here, totally random selection to get the subjects that we are going to use in our sample, this can still give us a biased result. Because like we talked about in the types of studies video, we could, for example, take a population of 50 men and 50 women and use a random number generator to split them into two groups. While that would be completely random and a simple random sample, that random number generator might just happen to divide our men and women into groups of 40 men and 10 women, and then 10 men and 40 women for group number 1 and group number 2. And that might skew our results because the men and women are so skewed across the two groups. So in order to fix things like that, we can do what's called a stratified random sample. And that's where we would do something like take our 50 men and we would use a random number generator to randomly divide them into two groups such that in group number 1, we have 25 men, and in group number 2, we have 25 men. But we split them up randomly using a random number generator. And then we take our 50 women and we divide them into the two groups, 25 into group 1 and 25 into group 2. We still used a random number generator to split them up, so the way we split the women was completely random. But now, because we've separated the men and the women, we have 25 men and 25 women in each group, so that's a stratified random sample that will help us control for an effect that gender might have on our survey or the study that we're doing. And then sometimes we'll do what's called a clustered random sample. And that's where we have a mix of samples. We create little clusters of samples, and then we pick small groups to be in our sample. So an example here would be instead of 50 men and 50 women, splitting them up into men and women, and then assigning 25 men and 25 women into each of two groups, we might create 10 groups first, each with 5 men and 5 women. And then each of these groups is a cluster. Then maybe for our sample, we just select 5 of these 10 groups, or 5 of the 10 clusters, these are really clusters, and we sample all the people in those 5 clusters. So there are lots of different ways to go about sampling, but the overall idea is that we want a random sample that avoids as much bias as we possibly can, and maybe depending on what kind of study we're doing, controls for things like gender or age or some other kind of variable that might confound our results, because it's getting a random sample, a truly random sample, that allows us to get an unbiased look at sample statistics that we can then use to make inferences about population parameters.